Next up is Glen Gawarkiewicz. He's a physical oceanographer from Woods Hole Oceanographic Institution and who studies physical processes on the shelf and coastal systems. And also, I will say, he's not just a modeler, he's not just a number cruncher, but he's been involved with cooperative research, which is obviously an approach that's near and dear to a lot of our hearts here. So I'm going to pass it off to Glen, and he's going to kind of pick up where I left off, talking about some physical processes that might be important and some more recent oceanographic observations. So thank you.
Thank you so much, Dave. I'm a fair bit outside of my comfort zone being here. I have had a big change in my career, actually, through those close interactions with the commercial fishing community. And I'll get to the shelf research fleet shortly there. But one of the big changes for me has been getting involved with the Squid Squad, which is an informal group that talks every Friday morning at 10 a.m. about fishing conditions, about regulatory issues, about Halloween costumes on occasion there. But it's forced me to really look at conditions in real time. And, you know, the normal scholarly approach is to wait 6 months, 12 months for those reviews to come back, and then, you know, really to work on a slower time scale. And so all my interactions have been just really stimulating and enriching. And I just want to, I won't list all the names there, but there's just been a lot of people that have contributed to my developing a story for how conditions have changed over the past year and a half. So just very quickly, I'll give a quick overview of the regional circulation and hydrography. Dave covered it a little bit with Kevin's material. I have one slide on the warming trends and the impacts on stratification. But a big part of the story over the last 20 years has been Gulf Stream meanders and rings. And as we'll see, the Gulf Stream did another funny, unexpected thing recently there, which led to a cold fresh pulse over about the last 14 months there. And then I will, since I was asked this in Chatham back in August, what's going to happen next? I don't have a model, but I will make a wild speculative guess there. Okay. So in terms of the circulation here, the Gulf Stream is a western boundary current. Let's see. Anyways, and it separates from the continental slope in near Cape Hatteras there. And it's a broad current. It carries a lot of heat up into the North Atlantic. But there's another really important current that really affects our region, which is the shelf break jet. And that's a much narrower feature. It's usually, I don't know, 6 to 10 nautical miles wide. It can be as strong as about half a knot there. On rare occasions, up to 3/4 of a knot there. But it tends to carry material down to the west and southwest there. The main way that the Gulf Stream interacts with the continental shelf circulation and temperature field there is through shedding these large eddies that are called warm core rings. They circulate clockwise there. Okay, great. And they frequently carry shelf water offshore. And one of the interesting things ecologically is that there's really strong upwelling up in the region where the shelf break jet deflects offshore. One of our former PhD students had an estimate of up to 100 meters or 300 feet a day in terms of upwelling in those regions there. And so those can be hotspots for various organisms. In terms of the water masses there, this is depth right here. That's the surface down to 150 meters, 450 feet there. The edge of the continental shelf is normally about at 100 meters depth south of New England there. And by the way, this is a climatology. This is based on 100 years worth of data. And this is for the summer conditions. In the summer, there's a sharp thermocline there. And this water mass down here is very important. It's called the cold pool. And that's been studied since Bigelow in the 1930s, I think, there. And there's a very large temperature front there. Okay. That's 4 to 6 degrees centigrade difference there typically. And it's coincident with a salinity gradient as well that's typically 2 practical salinity units or parts per thousand there. You can see the isotax right here. That's for the velocity of the shelf break jet there. And so it's primarily surface trapped there. So this is a cartoon of what my bread and butter, which is the study of shelf break processes there. And so the changes in colors here are schematic of the shelf break front. But one of the really significant ecological things in here is that there's persistent upwelling within that front. And more typically, it's 10 to 20 meters per day, so 30 to 60 feet per day. But it feeds right into the heart of the shelf break jet there. And we have a manuscript under review right now that a student from Italy wrote there that shows that this carries nitrate up into the surface layer. And generally it takes 2 to 4 days, and it can carry regenerated nutrients up into the jet there. So one of the really important changes over the last 20 years, I'll get to the Ring and Gulfstream story in a minute here, is that there's been a lot more intrusions. And so we've been seeing these mid-depth salty intrusions come in. The frequency has increased by 70% since the year 2000. So there's just been a lot more of these intrusions. And we've just started to study in the past few years these bottom intrusions. They can run all the way up to Block Island, actually. So they can go up to 60 nautical miles shoreward of the shelf break. It's just remarkable, these processes there. Okay, so I've been working for about 10 years now with Commercial Fisheries Research Foundation. And as a result of interactions having to do with the National Science Foundation Ocean Observatories Initiative Pioneer Array, I ended up getting involved with CFR. We were fortunate to get funding to start doing cooperative research there. And so we have a fleet there, and we give different vessels CTDs, conductivity, temperature, depth, instruments there. So we divided the continental shelf into 6 different zones. Zone 1 is the northernmost right here. And as of now, we have about 930 profiles that we've collected. And Aubrey played a big role in that there. And you can see the different locations there. But it's been really remarkable because we're measuring throughout the year. And I'll show monthly averages shortly. Whoop. Okay, so now the general issue of warming and extreme events. So this is a paper that Svenja Ryan and an undergraduate from Germany, Hendrik Grosse-Lindemann, had published back in 2021. The figure on the left is taken from sea surface temperature satellite imagery, and it's a spatial map of warming rates right there. And one of the things that's really interesting is that particularly the continental slope, and particularly on the south flank of Georges Bank, it's been having the highest warming rate there. Also, another thing that hasn't been looked into quite as much is the core of the Gulf Stream, actually, as it separates from Cape Hatteras, is also another local maximum in warming. Another really important thing are the extreme events there. And so you've probably heard about marine heat waves. I won't go into the details of the statistical definition there. But I will say that they've been occurring more frequently since 2010. You can see over here. And the intensity of them has increased as well. One of the biggest marine heat waves actually was 2012 there. That lasted over 6 months, and that was about a 4-degree Fahrenheit, 2-degree centigrade warm anomaly that really, really affected the ecosystem. Okay, so I guess it was around 2015, 2016, we had heard from Fred Matera at a Shelf Break Ecosystem workshop that the #1 thing that the commercial fishing community was reporting was more Gulf Stream water on the continental shelf. And I hadn't heard this from any academic sources there. And so I ended up getting connected to Avijit Gangopillai, one of my collaborators from SMAST, UMass Dartmouth there. And he was just starting to have a student work with these Jennifer Clark Gulf Stream analysis charts there. So these come out 3 times a week. And she's been doing this, I think, for over 40 years. And these charts denote where warm eddies are, cold eddies are. And he's had students who's used GIS systems to actually quantify these features there. So what has been happening with the Gulf Stream? And this is one of the contributors to the warming trend there. So in 2016, one of the colleagues in my department, Magdalena Andres, analyzed the sea surface height anomalies from the altimeter, the satellite altimeter. And she found something that was surprising, which was back in the mid-90s, the Gulf Stream was relatively straight. You can see the envelope of monthly averages here. But by 2014, you can see that the meanders were much larger, and they also began much further to the west than they used to. The red dot indicates a certain threshold for how big the meanders are there. And so it moved like 600 miles further to the west there. Again, we thought this was pretty surprising there. During the time that Magdalena was writing this paper, actually, Avijit and one of his students were producing the census, basically, that showed the number of warm core rings that formed each year. And it turned out that there was a real big change in the year 2000. And so there was a regime shift here. And we went from an average of 18 rings a year up to 33. And so, again, the Gulf Stream became much more active. Okay, so now back to the shelf research fleet. And this has just really been amazing to have the data coming in so regularly over this time period. This is a plot that Frank Barr, my colleague at Woods Hole, who's processed all of the CTD data, came up with here. So this shows the 6 different zones right here. And in each zone, it's the monthly average of the vertical profiles there. And my major point for showing this plot is that we normally see time periods where there's warm core rings coming out and interacting with the edge of the continental shelf. Again, this is offshore out here. And you can even see that for certain time periods, there's an increase in salinity even in the most shoreward box there. So this really does affect the whole continental shelf at times. But after discussions in March and April with the Squid Squad, I was hearing about colder conditions. And then I gave a talk about the oceanographic conditions the first week of May in Point Judith. And I was pointing out this wall of blue that appeared right here, that this was relatively fresh conditions there. And then this is temperature for the same time period. It's harder to interpret because of the seasonal cycle going back and forth, but there's some hint here that it's bluer, but we have better other sources that show it more clearly. Dave was talking a little bit about the fall and the spring conditions there. One of the amazing things that the shelf fleet data really allows us to do is really compare the years directly there. This is from zone 4, so this is on the outer part of the continental shelf, which I think is favorable scallop habitat there. These are in degrees Fahrenheit right here. And the different years are actually color coded. And you can see the remarkable differences from year to year for each September right there. So the range here is about 7 or 8 degrees Fahrenheit in terms of the interannual variability there. And October, similarly, there's just a huge spread. So the reason there's so much variability is that it really depends on individual synoptic meteorology events, storms that come through in particular there. And the timing of the storms determine when the stratification breaks down and you mix that warm surface water down to the bottom. And one of my students, Lucas Tanzer, actually had a paper published about a year ago using ocean observatory data to see the timing of the breakdown. The average is around October 15th, but based on 7 years of data, but it's plus or minus a month. So it really, really changes for the fall conditions. Okay, so now getting back to 2023 and 2024. So Avijit early in 2024 got together with his students and compiled the number of warm core rings for the year. And for 2023, to his surprise, there were only 18 warm core rings. And that, again, it's been 33 on average a year. And so the last year that there were as few as 18 forming was 1995 there. And so we were hearing on the Squid Squad calls about cold bottom temperatures there. And it wasn't until we had one of the Squid Squad calls in mid-May, Sarah Salwa and Kim Hyde usually show SST and surface chlorophyll values each week. And we talk about how the oceanographic processes are tying in with the fishing. On the left-hand panel, this is the sea surface temperature right here. So this is a 1-week average for the middle of May 2024. And essentially the blue colors here are the continental shelf water, colder, fresher. The dark red here is the Gulf Stream. And I just want to draw your attention to the anomaly plot here because, and this was when I was able to put in a lot of different details that I've been hearing in the calls together. Purple is a cold anomaly, and the lighter purple is 3 degrees centigrade or about 5 degrees Fahrenheit. The dark purple here is 5 degrees centigrade, 9 degrees Fahrenheit. And you can see the entire continental slope is purple there. I was amazed by how large this anomaly was and also its spatial scale. We talked about this a lot in the Squid Squad meetings because the ILEX didn't show up until very late. And when it did, it was much further to the south there, down near Wilmington Canyon. Similarly, longfin squid showed up late, and it's been south of Hudson Canyon there. So the entire ecosystem has been disrupted this year. We were hearing as early as March from a fisherman from Cape May, New Jersey, you know, the species I normally see are showing up 4 to 5 weeks late. And then I was out on a cruise the first week of June. We went from Morehead City, North Carolina, back to Woods Hole. And this was one of the profiles that we took. This was about 35 fathoms there. And the minimum temperature at the bottom here was 6.2 degrees centigrade or 43 degrees Fahrenheit there. The June before, it was 53 degrees there, which just gives you an indication, again, of these huge, huge year-to-year differences. Okay, so now the timing of this cold, fresh pulse. The student I work with, Lucas, is very energetic, and he's worked with the SMAP NASA product there for surface salinity. And what he did was he decided to make a time series of the surface salinity along 71 degrees west, where he'd taken some hydrography in November and noticed the cold, fresh conditions. So I just want to draw your attention to this middle plot because it's a salinity anomaly. And it turns out that there were 2 major pulses The first one was at the end of August 2023, right here, and it was centered at the shelf break. And this is exactly what you would expect from signals coming down from the north. Because of the shelf break jet, that's the fastest current. So you'll see those signals first at the shelf break. There was also a second pulse, though, in May that seemed to be more centered over the continental slope there. And so, we're trying to sort out the timing here. And there's already been a paper on it by our Gulf of Maine colleagues there, Record et al. This was in Oceanography magazine. This is a 3-month anomaly plot showing the cooler temperatures in the Gulf of Maine, and then also significantly temperature salinity properties at 250 meters depth. So this extends the depth. Here's 2024. Here's those recent warm years, and this one is definitely more like like 20 years ago, basically. So to conclude, despite the fact that there's been a long-term warming trend, a significant cooling event occurred. It was over the whole shelf slope region north of Cape Hatteras. It also had a 1 to 1.5 PSU fresh signal, and that extended from the beach in Rhode Island all the way out to the north wall of the Gulf Stream. We were actually in the Gulf Stream in the first week of June, and we confirmed there was shelf water directly abutting the Gulf Stream. There were 2 pulses, the first in August 2023 and the second early May 2024. And there's been really significant impacts to the ecosystem in terms of both the timing of appearance of species as well as the spatial distribution. So I'll stop there.